Okay. Hello, everyone. I hope you're having a great Wednesday. Thanks for joining us. Welcome to the Student Design Hub speaker series called Design Leaders in Tech. And in this speaker series, we have our local tech leaders from Newfoundland and Labrador come in and discuss how they approach product development. So a couple quick housekeeping things before we get started. You might notice that you can't see other people in the WebEx. You're not alone out there. We can see you all as attendees, but because of this platform, it doesn't share that with the attendees for some reason. So don't panic. It's not just you. If you have any questions throughout the session, just type them in the chat. So myself and Randy will be monitoring that the whole time, and we'll make sure we answer your questions all at the end. So if you want to ask Randy a question in person, I can actually promote you out of the audience, and you can pop on your mic and ask that question. So if you'd rather do that than type your question in the chat, you can just say, I'd like to answer, or I'd like to ask my question. And if you're having any technical difficulties, just send me a ping and I'll do my best to help you out troubleshoot. So without any further delay, I'm going to introduce Randy Billard, the co-founder and CEO of VirtualMarine Technologies. Sorry, VirtualMarine. It used to be VirtualMarine Technologies.
Right, and I think people can hear me okay. You hear me, Kyle? Give me a thumbs up.
Yep. No, we can hear you all well.
You're the only one I can see, so that's pretty good. But I can't see how many people are here. And can people's presentation up? Kyle, can you see it?
It's just popping up there now.
There now?
So, yeah, we can see the PowerPoint window.
And now you can see the full deal, I hope.
Yes, sir.
All right, and I'll go from here, Kyle. Is that okay?
Yes, sir. Sounds great.
Please just pipe in if anything goes incorrectly here. I don't have any fancy animations or videos and that sort of stuff. I'm not our CTO anymore, so technology is my back burner.
Sounds good.
Okay, so I just introduced, hi everyone. I can't see how many people are or what you're doing or smiling or shaking your fist at me, and that's probably a good thing. But I'll just introduce myself. I'm Randy Billard, President and CEO of VirtualMarine. We were VirtualMarine Technology, and people who know us from the university days may still want to call us that. But we did change our name a couple of years ago as we changed what we do as a company a couple of years ago too. I'm going to just give a bit of a presentation on who we are, where we came from, what we did, and why we're doing it. I understand you guys have had a series of lectures and speakers, all of which seem to be very high pedigree, so I don't know where I fit into this mix, but I'll do my best. But I'm going to try just to speak on something which probably wasn't covered by the other speakers, and if it was, I apologize for repeating, but there's some lessons learned that we have as a company which I'd like to speak to. I'll give a bit on who we are and what we do for those who don't know VirtualMarine. I want to speak quite a bit about our technology development, because we were one of those groups that came from a napkin to a concept to a prototype to write something that's commercially accepted worldwide. And I mean, that's probably important for the subject matter here today. But like anything, it comes with its own bumpy road of how we get there, especially from a startup company to who we are right now. And I'm going to keep it as light as possible. And if you got any very technical questions, feel free to ask them in the chat after. But I'm going to speak as lightly as I can about some lessons we learned along the way. Given that we're a tech company who's got a bit of a history of doing things right and also doing things wrong sometimes. And I think that's an important thing for us to speak to in this today, is that it's not always perfect, and that's really what the design process is. Okay, we are a Newfoundland and Labrador company. We spun out of the Memorial University and the Genesis Center in 2004. We had our 17th birthday last month. I'm very proud of that as someone who was with the company since day one. I remember our first days when we were a company that was sat at a desk in the engineering building. Up on the fourth floor, and we had nothing really other than a few monitors and a bunch of good ideas. But we've come a long way in 17 years, and I'm not going to speak fully on everything we do, but we've turned into a company that's servicing the world And that's something we're completely proud of. We were a 22-person team right now, but we work at any one time with anywhere from, like, I did a head count just this morning. We have 15 partners, 15 direct partners with in St. John's right now, just directly. That includes a workforce that we're helping at the university through some graduate students, and that's a flywheel we keep going through our research, and I'll speak a bit about that in our presentation. We're a technology and training company. We started off as a technology company building simulators, and that's actually the reason we dropped our VMT, a Virtual Marine Technology name, because we got just as well known for building training curriculum as we did technology. And as of this year, we've opened a site in St. John's to deliver training with the simulators we build, and that's something that that's just the evolution of our company. And something I won't speak to very much in this presentation, but that's how we evolved, given as from not just a technology provider, but someone who knows how to train using that technology, which is an expertise that the world was asking for. And that'll be the tone of most of my thing. We did what people wanted, and that's how we shaped ourselves. You're going to hear me talk a lot about our oil and gas applications today, but we have a diverse portfolio of clients. We do oil and gas, military, search and rescue, coast guards, cruise ships, the works, but I'll focus on one technology today, get some points across. And I got to say, we're very much an active in this community in St. John's right now. We have not had a year where we didn't have a research project with the university or one of our partner groups here in St. John's, and that's a big part of who we are. We're not just someone who took who came off the university and hasn't been working with them since. We're still very actively engaged with a lot of researchers at the university, in particular with the Faculty of Engineering and Applied Science. And I'll say Brian Bitch's name. I'm not sure if he made it here today or not, but that's how I got to meet Mr. Duty, and he can tell you that story later. And we're built on a marine and safety culture stemming out of Newfoundland, which is why we're here in Newfoundland. We could easily had this company go somewhere else in the world, but we're here for a reason, and I'll try and get that point across today as well. So here's why we came to be. And our primary product I'll speak to in a bit is a Lifeboat launching simulator. And here's how you currently train on how to operate a lifeboat. You would go to a facility such as at the Marine Institute and learn how to launch that lifeboat. That's the orange fiberglass thing you see up in the davit there. And you would do it in calm water. And these are great facilities. They're great training facilities, but in reality, and you do it in calm water because you don't want to put anybody in that lifeboat at risk. So things such as fires and faults and sea states are things you wouldn't put into a training program because it's just too dangerous. And in reality, this is what an offshore emergency could look like. 8 or 10 meter seas, gale winds. If you could imagine this being an actual emergency, there could be fire, smoke, easily a 50-50 chance that this happens at night or in fog and visibility is low. And if you think about how you would train in calm waters at a facility versus what we actually have to do in real life, there's quite a gap there in what you practice versus what you would have to do. And that was the eureka moment when we came on the scene in 2004, is that there is a way to train. Actually, I'll go ahead with myself first. The accidents are real. We got Piper Alpha, Deepwater Horizon, and local to us. And these are just examples of some of the accidents that happened where lifeboats were launched into the ocean, given where they were. When these accidents happen, it doesn't end up well for the people. And our big goal is to make sure people get training. However they get it, they're ready for these types of emergencies, because the emergencies aren't calm water. They're not without hazards. They're not without faults. And history has just proven that these things happen, and they happen regularly. Sad to say that accidents aboard oil and gas platforms and cruise ships and shipping vessels, they're happening all the time. And this goes to show there is quite a bit of risk associated with these types of operations, and we want to make sure people are ready for it. And that's where we came on the scene. In 2004, was working part of a research project that was started at the Moore University, Marine Institute, and NASA Research Council. And our eureka moment was, if we did what they did in the flight industry, and taught people how to land a plane with broken landing gear and with flames coming out of the wheels in a simulator, then if pilots can learn that way in a simulator, we can teach people how to do risky things in a lifeboat using the same sort of technology. And that's 17 years later, this is what we're offering. So lifeboat simulations is one of our primary products. It's our easily our most popular product to our oil and gas stakeholders, and also, as I mentioned before, cruise ships and such. And what you do is you can get in the simulator. You can launch a lifeboat in 6 7 meter seas. We can catch things on fire. We can make equipment faults happen. And if things do go awry and you end up hurting yourself or people in that lifeboat in the simulator, we push reset, and they just keep practicing over and over and over. And I probably don't have to sell much to the value of this. You can see how this makes people better prepared for emergencies and such. And these are now being used worldwide, and I'll speak to this in a little bit. But big thing is safer, of course, and it's more cost effective. It's actually when you look at the business model for doing simulation training versus putting people on planes instead of training facilities, it's a much more cost effective way to deliver the training. And there's certainly a business case to doing at least some portion of your training, if not most of your training, in the simulator, just on business case and risk alone. So that sounds like a slam dunk, really, but it's not. And that's the story I'm going to try and tell her today. We didn't just build a simulator and suddenly, yay, all the lights came on. There was a whole lot of work that we had to do to make the simulator what it is, and to convince a lot of people that simulation was the way to go. And that really drove our design, and it really drove how we approached the design. And that's what I hope I can speak to today is how we came to be based on what we learned over the last 15 years or so. I was going to show a video, but I'll just show some pictures. I can show some video after we have some time. I'll just keep an eye on our clock because I don't want to use the full amount of time to ask questions, get some questions in. But these are the type of simulators we're building. They can be as small as something that fits on a desktop, is in the top right-hand corner. Or they could be as big as something that sits on a motion bed and is 2 stories high, or they could be first-person simulators, as you see in the top left. But we have a number of different types and types of simulators. And I won't get too much into the technology itself today. If anyone wants to check us out, I'll send some web links and such to Kyle. He can pass them around. But these are pretty much what the traditional version of simulator when it comes to training. It's an immersive virtual environment with hands-on equipment, and you learn how to do stuff in the simulator that you can't practice in real life, because we can put you in situations in a simulator that don't put you in at high amounts of risk and such. So hopefully these pictures show it. But this is where we've come in the last 17 years, and I'll speak to that in a bit. We are a software and hardware company. A lot of the work that we're doing and what's really behind our core technology is a math and physics engine that allows us to scale our technologies to the different types of marine operations. We focus primarily on small boats. That's what we get good at. So things such as lifeboats or fast response boats, tugboats. But we also got really good at navigation equipment and bridge simulations and such. So we bring everything back to our core simulation engine, which is pretty much an numerical modeling engine that plays very well with visual engines and motion beds and everything that we need to put together to build a simulation. So we're here in St. John's because this is where the expertise is in both marine simulation as well as harsh environment modeling, which is where what we're really driving as our number one potential is that we can teach you how to do stuff in really complicated situations and harsh environments. And we work with the community of expertise here in St. John's because we don't have to worry about going to look for her. We were a company out of Florida, and we needed to do ice simulations. We had to go to St. John's to do these sorts of things. But in St. John's, all the crappy weather comes to us, not harsh environments. So what a nice little playground to be able to build a company that's focused on preparing people for the worst type of weather conditions that's out there. So over the last 15 years, we have been very active in working with the community of expertise in St. John's to build our library of not just boat simulations, but the environmental models and the harsh environment models, including ice, including high sea states and such, and bringing that into our core software. So, and people actually come to us in St. John's, and we tour them around the university and say, hey, this is where all the expertise is in these types of harsh environment modeling. And they realize that they've come to where the core expertise in these fields. And that's really been what a big plus for us as a company, not just being formed here, but continuing to work with the expertise here in Newfoundland. And we're very proud to be part of this community. So I'll that's enough on us. And if you got any questions, feel free to bring them up in the chat after. I'm sorry, I'm doing a little bit of sunlight, which is a terrible Newfoundland problem. I shouldn't be complaining about it, but just gonna move myself around a bit. So I'll speak a bit now to our journey a bit, and some lessons we learned along the way. And I'm going to try and keep this as light as possible. And if again you want to know more details on anything we talk about here, feel free to pop it in. But I guess in our 17-year existence as a technology provider, we recognize what we are now, but probably look through different types of glasses 17 years ago. But we were, and we still are, a very disruptive technology. We came on the scene in 2004 with our first version of a lifeboat simulator, which, and I'll date myself and probably other people who are here. This was before the time when you could go to Walmart and get an LED projector screen, or LED TV for $500. You couldn't do this back in 2004. The LEDs and LCDs were new technology at the time. So our simulators were, I'm not sure if you see my mouse or not, but if you look at this first picture, it was our first simulators had huge projection screens we had to shoot into, and it was built of this hunky little fiberglass. But we had to use that prototype we built back in 2005 to demonstrate, to get our first version of our simulator out there. But that was the easy part. Building the simulator was actually the easy part. We had to then convince industry, which let's just focus primarily on oil and gas, that the simulator we had built was something that could be used or would be used and is acceptable for training for people going offshore. So that was our biggest challenge. And we were tickled pink by what we had built in 2 or 3 years' time. But a lot of the work that we had to do over the next 5 or 6 years, and it did take that long, was to convince industry that simulation was as good as or better than the current training practices that were being used in the industry at that time. And that is and still continues to be our biggest challenge. We can build really good simulation environments. We can make them look really good. We can really show the training value through studies and such. We're really having to change the way that people are currently doing their training, and that has fed back into our design cycle in so many ways. It's helped us, it's made us change, what we have to do with our core features, what we have to do with our core training programs, and it's really directed in making the case that simulation is a good or better way to train than what's currently being used in industry. And I gotta say, that's as someone, if anyone's here is thinking about building something that is a replacement for or an improvement on the current way people do things, you immediately got to put yourself into the mindset that you got to convince those people that and those clients that what you have there is better or more is better than what they're currently using. Change is a really hard thing for a lot of groups. And I also want to put a slide up, and I'm not going to speak anything in detail on this slide. It took us quite a bit of time to get there. So from a prototype that we started in 2003, 2004, it took us 5 years to get our first simulator out in the market. And that's because we had to get not just acceptance that the simulator was a good product, but acceptance that the simulator could be used for training based on what it did and how it was doing it. And I just want to put that again into perspective that this is a lot of people think that coming into these design things that these are 2 or 3 year projects. When you're trying to do some of this boiling the ocean work, it's quite a long process, and we're by no means done boiling the ocean, but it certainly required quite a lot of effort, not from the technology side and from our regulatory approval side to get there. And I won't get too much into that today, but I will speak to little tidbits on this as we go forward. And I'm also just presenting something on the slide about how we measure progress. I mean, we'll talk to TRLs and such in a second, but the other thing to show is that our simulators have changed quite a bit from what they were. They used to be big fiberglass projection screens, and you'll see we've changed them into something that are much more versatile. And I'll speak to that story in a second. Well, that's where we started. We started back in 2004 with an unproven technology, and it wasn't accepted for training, and we had no users. And in 2021, we're just about to announce we've delivered our 100th simulator across the world, and we've got 12 different regulatory approvals on our simulations right now. And this took quite a substantial amount of work, but we're not done. Every time we go to a new country, and you'll see in this map right now, there are some countries which aren't represented where we don't have simulators, because we are one by one going into these countries and these jurisdictions saying, well, we need to get regulatory approval on the use of these simulators before we can start selling to these countries. And Asia, for example, being one of them, we've got some work to do there before we can sell into different parts of Asia, and that's where we are. And it's quite a bit of work, but we've come a long way. And just one of those, it's like the electric car sort of deal, and proving that there's autonomous cars that are out there. I mean, this generation, we could probably say, well, these autonomous cars and these electric cars are the way to go, but that's not where that vision started. Started with, well, here's a different type of car, different type of system, and here's what we had to prove, including all the safety things with that car, that it's as good or better than the car that came before it. Probably not the best analogy in the world, but you can see that these things take quite a bit of time to get to the right place. So how do we do it? And this is something I'll speak to, but not give a lot of detail on. We iterated quite a bit, and this is really like the really main point I want to make here is that we thought back in 2004 when we got a simulator out that people just buy it because it had good value. No. We had a lot of work to do on getting the system down to where it was. We had to listen a lot to our first users, a lot to our clients, and we're in a continuous improvement exercise all the time, and we still are. And that shouldn't be any surprise to any technology company, given that stuff changes so quickly. But moving from projector screens to LCD screens is one thing, but moving from something that was 2 stories tall, I think these bottom series of pictures here right now, to something that actually works on a desktop with a VR headset. We got there because we listened to the needs of our clients, and I'll just speak a bit about that. I mean, we thought that our primary market was going to be training schools. When we would sell these systems to schools that deliver lifeboat training, and they would have the infrastructure available to build these to take these 2-story simulators and do the training. It turns out that our biggest market is people who want to do on-job training and do training while they're on site. So these desktop simulators that you see in the bottom right picture here, we built those because they can go on board an oil and gas platform and take up as little real estate as possible, because there's not a lot of real estate on these oil and gas platforms. And once they're done with it, they can put it away in a Pelican case and they're done. So we sell more simulators to on-site training than we do to training schools right now, which was not our original model. And that really forced us to change our technology footprint, to go from something that was an instructor-led simulator to something that was autonomous with embedded training curriculum and such. And we learned that the biggest thing that drove our technology is what our clients needed, not what we thought they needed. And this is one of those, when you go by how we did it. We I'll get this deeper in a second, but we iterated quite a bit on this, and we're still iterating. But that's how much the technology has changed over the last little bit, and even things such as I mean, our key challenges like I listed there. I mean, technology is a fluid platform. Also, 14, 15 years ago, engines such as Unity and Unreal didn't exist either, or not in the magnitude they do right now. And so we're always looking to take the best available technology and bring it into our simulators. But and we'll keep doing so. But our other key challenge, as I mentioned before, is that we had to convince people that this was as good or better than what they were doing. And change is not always good for companies or clients. So us having to convince our clients that there's a better way to train is a big fight. Us having to look back at what we designed and used over the previous 4 or 5 years, not even 10 years, and say we need to change that because it wasn't the form that was hitting the mark with our clients. I got to say, it's a little bit belittling to an engineering team because we thought we had the right thing done, but we didn't. But it's also shaped our culture. We don't get offended when a client comes to us right now and says, "Hey, that's not what I wanted." Well, tell us what you want. That's our next question, and that's pretty much our design process right now. And it's not as simple as that, but a lot of the work that we're doing right now, and people are starting to use our simulator, a lot of research we're doing is driven by what the client says they want to see happen. And that's a critical part of our R&D right now. So I'll get into some lessons learned. And again, these are meant to be light. This mentality of build it and they will come. We went through this, and it might work sometimes, but it's a flawed philosophy. And for anyone who's got in their heads that they get a design that they think is right, and if they haven't sounded off the client base, and they're investing a whole lot of money into that product, but speaking to their client base, I mean, I think there's a danger sign being raised when we say that. It could be the best. As I mentioned earlier, we thought we had a really good technology, and then the value was easy to see, but it took us 6-7 years to convince the world that it was actually worthwhile. And that's something that I think that anybody who's coming into the game with a new innovation, new technology, really has to make sure that they don't do things in their own silo. And complementary to that, you may have a really good technology, but you've got to value that with what the client actually sees as value. I'm sorry, maybe I screwed up that word, or that sentence. Sorry, but I say a customer's not going to overpay for something if they don't believe it's worth something, or if you don't have the money to do so. So if you've got a perpetual motion machine that's going to cost $10 million, and a customer's only got $5, they're never going to buy it because they only got $5. In our case, this was we built a really good simulator, but the simulator wasn't approved for training in local jurisdictions. So it's as good as it was, people couldn't use it, and that put us then on the road of getting the simulator approved and accepted by regulatory authorities and certification societies to say, well, the other simulator is actually good to use. And in our design right now, we involve the client quite a bit. We don't just especially for big systems that we design. So just the system you see on the slide right now was designed with one of our clients in mind. They had a vision of what they wanted to see. They proposed a vision to us. We iterated on it several times till we got them into our design process, and they liked it. So that's also something we do too. If you think the client's going to be if you want to know if your client's going to use it, you could also say, well, what do you want to see in the design? And that will drive a lot of what of your technology roadmap, which is a great way. You're not guessing anymore then when you do that. The other, I want to speak, I'm not sure if anybody in your previous speaker series talked about this, but building technology with client in the loop is not a is a very important process that is used in a lot of industry. I'll just throw some concepts out there, and you guys can look at them after. But we rely heavily on what's called a verification, validation, and accreditation process in our company. It's the language of our company right now, and we're always asking ourselves the question: am I building the right product for our clients, and am I building the product right? And those two tug of war into each other quite a bit. And we use this in our engineering team. Like, how are we validating how am I validating that the user really wants this product? And the main vehicle we have to do that is to get them to test it. And that helps us to define the requirements for our product. The verification is that I build exactly what I said I was going to build. And that's normally where most engineers stick to. I'm going to define my requirements. I'm going to make sure it works. And I find that, that's an exercise we have to do in our company quite a bit. It's like, hey, you built it, but is it what the client wants? And not having that closure in your loop can really force you into a mode where you're spending a lot of time on a feature that is either not of high value to the client or is useless to the client. And if that's what you're doing, focus most of your time on the features which are important and valid to your clients, and stay there. I said verification, validation, accreditation. Accreditation in this mix would be getting accepted by an authority, like a certification body like D&D or such, on did you build it, and does it conform to regulatory standards? And I won't speak to that one today, but that would be the DB&A process. I'm saying that because there's probably anybody who's interested in this process, there's lots of references out there on this, and I can point them to Mr. Duty, and he can test them on if needed. I'll also say that, speaking the language of industry, this is just to reiterate again, this is not an unknown process. I mean, NASA, for example, you guys may or may not heard of technology readiness levels, and I had it in my slide previously. TRL is basically define where your product is in its life cycle, from being a prototype to be something that's commercially accepted. And the point I want to make here is that NASA's, of course, being a huge engineering or well-known engineering group, as you move up from something that's a TRL1, which is a basic napkin drawing, to something that's TRL5, where you've got prototypes and such made, it quickly moves into, you've got to take that technology and get it into the client's hands, or get it demonstrated in a real operational setting to prove that it's the right thing that you have for your client. So there's scales that you can adopt to actually measure where your technology is in your thinking, but also in your design process. And being able to label it these sorts of categories may actually help you define what to do next with it. So if you've got a technology which is really good, but it hasn't been tested by a client yet, that means you're only halfway there. And you can iterate up and down on this TRL scale quite a bit based on where the technology is. So I just want to throw it out there again, and I won't get too deep into it. Is if you're trying to assess where you are with your technology, there are some tools at your play that you can use to measure and then relate to some of the other industries that are out there. And there's a number of different TRL scales. There's one that's adopted by the oil and gas industry. It's the API scale. I picked NASA because it's one of them. But again, just to bring a point home, I mean, and this is why we always go through a design by iteration phase. We will often send things to our clients that's a new design which we haven't tested extensively, just to get their feedback first, and then see how it drives the rest of our design. And that's the design by iteration approach we use quite a bit. There's also something, just a design mentality conversation. This is just probably more light than anything else, but as you're doing your design, I think it's a good idea to think about what perspective you're looking at your design on. There's a really light book out there. It's called the E-Myth. It's up in the top corner of the slide. It's a simple read. You can read it in a weekend. maybe some of you guys have already read it, but it's a very light book. But I tell you, it's something that I read, I guess maybe even 20 years ago now, and almost 20 years, and I still use this every day in our company. But it's good to know as you're looking at your product and your design, how it's being perceived by people within your company, and how it could help or hinder what you do next with that product. So I'll explain this very loosely. There's three types of personalities in most companies. There's the entrepreneur who's always looking forward to where the product has to go, and always looking at the world and looking at what's changing in the world and saying, how do we shape our technology to certain needs? You got the manager who normally is resistant to change, loves it when nothing changes, and loves the process involved with changes. And whether you're in design groups or you're in design teams, even in your university, you almost sense which one of these molecules you're going to be. Manager being one who likes to make sure that everything's by the book and has to see order and doesn't like chaos in any design. And then there's a technician, the third one, which is basically I need to be doing something. So it's either I'm going to do what I think is best, or someone's going to tell me to do it, and I'm going to go off and do it right away, regardless of what they're thinking of whether this just causes pain to our team or whatnot. I'm going to be right at the gate. I'm going to say I'm always on the technician side. If I always need to be doing something, and that's been quite a challenge for me as someone who always wants to keep moving. But that's put me into the mentality of being someone who's designing by iteration versus just waiting for the product to get perfect before we send it out to market. So I'll just give a very light example of how these three parts of the molecule work. And this happens every day, every other day in our company, and sometimes we move around these roles quite a bit. I was just thinking, like, and this is a very simple example. For example, if someone came into our office right now and said, I would like your product. It was like pink is the new color for simulation. I want you to make sure that you're adopting the new pink color, and we're really because I think this is the way the world's going, this is the way the market's going. And I know your colors are orange and blue, VirtualMarine, but I think we should move it to pink. And a visionary walk into the office and say, you know what? I think we're going to sell more product if we painted it pink. If that visionary went to the manager and said, first thing the manager's going to say, we have never painted any pink before. Why would we do it? So they're going to challenge the visionary right away. Technician is going to say, I don't care. Pink, can I go buy some pink paint? Just give me something to do. Argument circles. Entrepreneur, I hear that pink is a hot color. None of our competitors have it. So they're trying to validate where the products should go based on what they think is best. The manager's starting to get upset right now. That means we'll have to change the way we do things. It'll cost money and time. So they're already saying, don't go fast enough. Technicians getting irritated. What are you guys doing? Can I buy the paint or not? And an entrepreneur normally falls into the visionary and executive role of the company. People will buy it. Let's revamp our marketing campaign and spend $1 million. Manager has a slight heart attack, and meanwhile, the technician already got on and bought the paint. So when you're looking at your design, sometimes it's good if you think you're in a rut in any of these. If you think you're doing a bunch of stuff but don't know why you're doing it, you're the technician. If you think you're not getting anywhere with it and nothing's changing, you're more the manager molecule. If you're thinking about where it needs to go but nothing's getting done, you could be the entrepreneur molecule and a part of the molecule. And it's very important as you're doing your design to put yourself in these three roles as you're evaluating where your technology actually is. Because if you just imagine any of those two molecules together, and if you just have the manager and a technician, you'll have a bunch of stuff getting done, but it'll never change. If you have the entrepreneur and the technician, you'll be doing a bunch of interesting stuff, but you'll probably be doing it regardless of time and money, and that puts you in, could put you in financial chaos. If you have a manager and an entrepreneur, you'll have lots of good ideas and lots of processes to get it done, but you'll have no one to execute on the work. And I try and encourage our team to put yourself in the lens of these three parts of the molecule as much as they can when they're going through the design phase, because it quickly turns into, well, I never thought of why that aspect of my design is important. Whether it's whether I'm doing it for change, I'm doing it for speed, or I'm doing it to minimize my costs, which are all things that companies have to think of when they're doing the design. So this is light, but I think it's something that may or may not help you guys as a resource. The other thing is about make sure your research evolves too. As I mentioned, we were a company that continues that we were and we still are a company that has a lot of activity with the university here in Newfoundland, and our research has changed quite a bit in terms of what we do. And it's really become dependent on the shape of our products and where they are in the TRL scale. We started off as a napkin, and as I mentioned, we had to go from technology that was not even built to something that was accepted or proven and accepted, and now we're moving on to preferred by our clients. And the first round of our research was really about getting that widget built, and we spent many years doing that. We spent another block of years in our research getting our simulation into a value proposition for our clients, into training courses and developing training courses around the simulation. That still wasn't good enough, really. We then worked with the university and did a lot of human factor studies to prove that simulation was actually work. And as we were doing so, we were getting regulatory approval, because this is what the regulatory authorities needed to see, that you didn't just have a technology, you had a technology that was suitable and could be used by clients for training. And we geared up a full 3 or 4 year research program doing exactly that, putting our simulations into human factor studies to demonstrate that people could acquire skills and that there was value to our customer as either cost reduction or a way to people to acquire skills that they couldn't get in regular training. Now we're at another mode where we move from being an accepted technology to preferred way that people want to train. So now we're in competitive mode, and all our research now is how do we take the simulation technology that we have and make it such that it's engaging for our users, that it's smart enough that it can read our users, watch our users' behaviors and adapt to their individual needs and such. And now we've got a full research suite geared exactly on that, is how do we take our simulation technologies and make them stuff that they're built to keep people engaged, to automatically track people, using machine learning and artificial intelligence to make the simulation more valuable for the user and for us, given the data we're collecting in these simulations. And this type of research we're doing today is nowhere near the type of research that we did the first 4 or 5 years in our company. And as I mentioned, we've been doing it for 17 years, and we've done millions and millions of dollars of research. But and being built on that research also gives us credibility, because we can at any one time we can pull out, between us and the university, we pumped out I don't know the exact number, but well over 100 papers on simulators. And some of those papers were about, here's a new technology, and some of those papers were about, here's a human factor studies done with that technology. And now some of those papers are on machine learning and human performance modeling that uses data that comes from these simulations, and that just gives us a whole lot of credibility. And again, we just think that's really how companies have to do it as their technology improves, if they're one of those technologies that continues to be heavily engaged in the research. And this is the last lesson. I'll wrap up there, because I didn't realize I went so long. Never forget why you're doing it. So I'm going to say we're obviously a business. We want to make money, and that's what really keeps our stakeholders and our banks and such happy, that we're making money and such. But our primary goal is to keep people safe and make sure that when we build these simulators, that we're putting people in training environments that they get the skills needed and the confidence needed to get home to their families, or confidence needed to perform in an emergency and ultimately get home to their families if there is an emergency that requires them to apply their skills. So this is a gentleman who went through one of our first training courses in Qatar, and his feedback back to us is, I'm a lifeboat captain, but I'd never practiced launching a lifeboat into anything that I tried in the simulator. And he said, I feel much better now about my abilities now that I've gone through your training program than I did what the training program did in the past, which were in calm water. And I think that helps us, because that means that we're making this person more confident, making them more capable. And I mean, in addition to making money, we want to make people safe, make sure they're ready. And that's what's driving us as a company, driving all of the employees in our company, the fact that we're doing this sort of stuff. And whether you're doing that for entertainment, whether you're doing it for whether you're doing it for safety, whether you're doing it just to make a load of money, make sure that as you're doing your design, you don't get lost in the process. Remember that you're doing it for a certain person, for a certain reason. And ultimately, if that's to keep your clients happy, figure what's going to make your clients happy and go with that. And that's it. I've rambled for 45 minutes. Sorry, Kyle, if that took more time than you expected, but I'll shut up now.
Thanks for the presentation, Randy. As always, it was really informative, and I have some questions queued up, but I encourage every one of our attendees out there to, if you have any questions for Randy, Randy has lots of context that he can put behind those answers that you might to the questions you might have. So he's been around the block when it comes to product development and the design process. So if you have any questions, please pop them in the chat. I'm sure he'd love to answer them for you. So Randy, one question that a lot of students seem to want to know about is I understand your background, or your bachelor's degree, was in mechanical engineering. Is that right?
Correct.
Yeah. So did you find that having a bachelor's degree in mechanical engineering kind of hindered your ability to move into this this type of research and product space?
Well, so I'm a mechanical background, naval masters, and then human factors PhD, and so none of it makes any sense really. But I think your background as any engineer is your problem solver, and I was always a design person by heart, and and this is why I really like the team I'm working at right now. I work with a bunch of problem solvers, and there's no way, and I'm not going to try and, it's not a hit on the university. There's no way you're going to learn in your university program all the different types of problems you're going to experience as an engineer. But I will say the engineering program certainly geared me, as well as the people who we have hired here, and we have many engineers with our company, to be really, really good problem solvers. And I think that's my takeaway from going through the engineering program, is that they gear people to really turn into people who can understand that they got a problem at hand, but quickly move into deconstructing it to there's a way. I know this is a problem. Let's talk about the problem. Let's talk about how we can solve it, and move into problem solving really quick. And that's actually something that I find our team does really well. I'm very passionate about that. That here, my golden rule in the company is, let's talk 1 minute about the problem and 9 minutes about solving it. And that's everyone gets that when they come talk to me. You can come to me with a problem anytime you want, whether it's a person problem or an engineering problem. Got your problem? How are we going to fix it? And I find that's what my brain is geared, and I think that's the way a lot of engineers are geared.
Yeah, and I think it's a great way to approach problem solving, and I really like that model that you brought up with the entrepreneur, the manager, and the technician. I think it really hits the nail on the head after working in industry myself. And
I dare anybody who feels they're one part of that molecule to change your perspective and ask questions back to your team and see what happens. And you will see that it'll cause quite a disturbance, and that's what you want to see. Just try it, purposely move outside of your comfort zone and into another role for just one conversation. See what happens.
And I'm going to encourage students to do that. We have a question from Mubarak. How hard is it to get investors? Are there any criteria that investors look for or look into before putting their faith in a business?
Business case. Are people going to buy it? So man, I'll just throw it. If it sounds simple, but if you, again, it goes back to the core thing. You might have the best technology in the world, but if you can't make money off it, or you can't see how it scales into a big opportunity, it's just a good idea. And I know that sounds sad because there's a lot of really good ideas that don't have good business cases. And when you're talking to an investor, they just want to see, okay, like you're not all, and not all of investors are shaped a certain way, but their primary thing is how am I going, if I invest money in this, how am I going to make money out of it? And that story is really the business case. Who's going to buy it? Who's going to pay for it? How much going to pay? How much going to pay? How big is the market? So that's and yeah, that's a attractive.
Okay, perfect. Thanks, Randy. Did that answer your question, Mubarak? Everybody out there in the audience, please feel free to put some more questions in the chat there. So, Randy, you talked about replacing and improving existing technology, and that a key piece of that is convincing others that your technology is better. How did you go about demonstrating that? Like, was it mostly through the research that you completed, or were there other methods you found really effective?
Well, I mean, better's a an opinion, I guess. But you know, scientifically, we proved it through studies. So we did and this, I'll give another angle in a second. Um, we did a lot of human factor studies to demonstrate that how people learned or acquired or demonstrated their skills in the simulator was as good or better than how people were currently doing their training. And we had to do quite a lot of research to demonstrate that. It sounds you can't simply go and say, well, the flight industry is doing this, it'll work for you too. But you got to demonstrate it in the context of people doing lifeboat training, for example. And you know, that scientific credibility is one thing. The other thing that we find, and this is why I always, again, I go back to the point, and it wasn't clear in my presentation, I'll make it right now. Get stuff into your client's hands so they can buy into it and believe it. And we do this more now than we ever did. But to demonstrate it's better, you just give it to them and say, play with it, and we're going to show you. Go, and you know, and I know my investors would probably hate me saying this, but if I had my time back, I would have given away my first 5 simulators, and said that I couldn't do it, of course, but I would have given it away so people can see. Oh, actually, this is better, and I get it. And then once they get it and they can talk about it, then it's a peer-to-peer discussion, right? Now, you know, I heard Joe likes your simulator. Tell me about it, right? And Jill will pick it up and say, you know, Joe, and I'm Jill. I heard about Joe's simulator, but you know, all those other sort of stuff, and that word of mouth and buy-in is what really drives the next, the bigger community buying into your product. And that's get the client engaged, get them in your design, let them hear what they want, and sometimes hearing your client say, you know what, I like it, but if you just did this one thing, it'd be perfect. Do that one thing, give it back to them, and then it is better, just like that, right?
Yeah, and it's amazing.
We're very much a client-driven company right now. We listen, and we have we're an engineering team because we change the design routinely for that reason.
Yeah, and it's amazing how quickly, you know, a product can get disqualified based on one or two, you know, minor criteria, you know, for convenience sakes. So it's really good to hear that, you know, you're doing that iterative cycle and you're engaging your client, because I think in all engineering projects, you know, ensuring that your client, and you take the client mentality about your product, really drives home the value of it.
Yep.
So we have a question from Zarin here. How do you monitor your product's performance that were sold to existing customers? Do you have any special mechanisms to improve your sold products or your existing products?
Well, monitor performance. I mean, we are as a product company and a software company, we're both. So whenever we put a product out into the field, it comes with a standard warranty and in-service support contract and these sorts of things. So you know, we have a full part of our team which is in-service and support, making sure our simulators up and running and such. But behind all the products we have is software that changes quite a bit, and I mean routinely. I mean monthly sometimes. But we do product release cycles at least twice a year, and as I mentioned, we're getting feedback from our clients. Like we got simulators we got 90 odd simulators out in the road right now. We're getting 90 odd pieces of feedback from our clients. That drives what we do with our software. Our software changes, and then what we do is we issue back software upgrades to people who have systems in the field based on what we think is the collective best need for our product. If it's a bug, we fix it, but if it's also actually we can do this better if we just change some stuff. And it's not always we just do a full suite change in our software. Sometimes we do bespoke changes to our software based on specific feedback we get from our client for one application and such. Biggest thing in this is like monitoring performance is give them a vehicle to talk to you, like check in with them or give them an email or a portal where they can tell you what they like and what they don't like, and then you can deal with the information and change it as you see fit.
Perfect. Thanks, Randy. Zarin, does that answer your question? Okay, next question is from Dan. Could you ask Randy to touch on his thought process for doing a PhD while being in charge of a company? What were his reasons to do so?
Insanity. No, actually, well, here's the deal. I mean, our company is built on our research. I'm one of our researchers, and the type of research we were doing was going to be done by either someone in the company or someone that the company sponsored to do research on our behalf. Now, I do have a bit of flexibility in defining what I want to do, which is, I guess, a bit of the gift. But this was actually a very important part of our company's plan to put someone in a role where they could defend and answer and even ask the questions on research about how simulations work and how our simulators work. So when people come to us right now and they say, demonstrate to me or talk to me about how simulation works or how Lifeboat simulation works, I can do it because I can speak right to the levels that say, the science levels or the evidence levels that say, I know I can demonstrate and I can talk to how this works in a very scientific way and give them comfort that they're not just getting a game. And this is not, that's really, I mean, that you might look at some of these simulation images and say, this is a game done for whatever, but no, it's not a game. And being someone who can speak to that research was a big plus for our company. And I just put myself in the chair of being that head researcher, and that was the company sponsored it, and that's actually something that we're very again. I mentioned people come to St. John's to hear about the expertise that's working on marine simulations, and we're one of them. And they're looking at us and saying, well, you got this guy in your company who's actually I'll say expert in it because he's done his research studies on it. So it was I can't say it was a no-brainer, but that was what was behind us bringing that sort of expertise in their company. I just put my hand up to be it.
Perfect. Does that answer your question, Dan? Great from Dan. Excellent. So everyone, that's just about our time. I want to say a big thank you to Randy for coming and giving this presentation. I hope everyone in the audience found it helpful and informative. And if you think of any questions after this presentation, you can send me an email, and I'd be happy to forward those along to Randy. My email is kdoody@mun.ca. So send me anything you want to ask Randy, and I'm sure he'd be more than happy to field your questions. But thank you all so much for attending, and a big thank you for Randy for taking the time out of his busy day to come and chat with us.
All right. Thanks for listening, people.
All righty.